In this session, we'll discuss stationary points, and these are the points called stationary point, where the function temporary, the gradient becomes zero for momentarily. So, so this is also called stationary points or turning points, and these turning points could be a minimum or a maximum. So this point Q, this in this case, this is a maximum point. Here in this case, it is a minimum point. So in the maximum point, if we reach maximum point, the left hand slope is a positive slope, while the right hand slope is a negative slope. On the other hand, if for a minimum point, the right hand or left hand slope is a negative slope, and then a rising slope is a positive slope. So this is the minimum point, and this is the maximum point. So the maximum point and minimum point both have dy by dx is 0 for this function, and the gradient is positive to the left, is positive for a maximum point, and then negative for the minimum point. So, and some point where the values turning point is called point of inflection, the stationary point, from the positive to 0 and then positive again, positive to 0 and then positive again. This is called, similarly for negative and then step, uh, 0 and then negative again, this is called point of inflection. This kind of stationary points are called point of inflection. So the stationary point is where the gradient is 0, is called the stationary point or turning point. At maximum point, dy by dx is equal to 0. The gradient is positive to the left and this side, and negative on the right, this side. Similarly, for the minimum point, dy by dx 0 again, this is a stationary point. On the left hand side, it is negative. On the right, it has a positive. So the point of inflection is this kind of point where the rising and then stay and then again positive, similarly the negative and then stationary point and then again negative. This kind of function is gives inflection point. So if dy by dx is equal to 0 or dy by double derivatives of this is less than 0, then the point is at the maximum point. So the derivative is negative, so the maximum point has reached, and the second derivative is giving you a negative value less than 0. This means the point is maximum. If dy by dx 0 and the second derivative gives a positive value, means the slope is rising like this. The slope is rising. So this is slope is decreasing and this is slope is rising. So this slope rising means this is the point is minimum, so it is rising. So this is gives a minimum point. So the point, this dy by dx is 0 means stationary point has reached, and then it rising means that this stationary point is a minimum point. If this stationary point is 0, then again the slope is giving a negative slope, means that this stationary point is a maximum point. So we will solve exercise 12.9. There are A to F, and for find the coordinates of the stationary point on each of the following curves and determine the nature of each of the stationary points. So for A to F, so let's solve the part A. This y is equal to x square minus 12x is equal to 0. Take the differentiate, first differentiate, and this gives this value. This x square is equal to 2x, and this 2x 12x then becomes 12 equal to 0. This is a stationary point. So this gives us x minus 6, 2 common, and x minus 6 is equal to 0 means x is equal to 6. So placing x at x is equal to 6, this y gives minus 28. So the stationary point is 6 and minus 28. Now text the second derivative, and for this second derivative we have 2. this is 2. We should eliminate this because this 2x, so this x will eliminate, so this is 2, only 2. So at x is equal to 6, this 2 is positive, so this is a stationary point. So 6 minus 2, 8 is a minimum point. So this is only 2, this is only 2, this should be eliminated. This x is not correct. So d 2 dy by dx square is equal to 2, only 2, which is positive. So this is stationary point, and this is 6 to 8 is the minimum point. Similarly for part D, where we have y is equal to x cube plus x square minus 16 minus 16, 16x minus 16 takes the first derivative. This is 3x square, this is 2x minus 16 is equal to 0, and this becomes we take out the factors, and 16 48 factors is 8 into 6 plus 8 minus 6 because of minus 48. So takes out this, and we have factorized to get x minus 2 is equal to 0, 3x plus 8 is equal to 0, x is equal to 2, or x is equal to minus 8 upon 3. So at x is equal to 2, we have y is equal to this. The stationary point is this 2 and x minus 3. So for 8, x is equal to 8 by minus 3, we have this 400 by 27. So the stationary points is this. For this at this point we have this, and this is greater than 0 at this device maximum point. This at this value takes the derivative of this one, and the second derivative of this is the second derivative. It becomes 6x. This 6x, or second derivative is 6x plus 2, 6x plus 2. We take the second derivative, and this becomes 6x. This is 6x plus 2. So this is d double derivative of y dx square is equal to 6x plus 2. So at this point 6x plus 2, we put the value x is equal to 2. This gives us a positive value. So at this x is equal to 2, this is a minimum point because the function is rising. So this is positive, so this point is 2 minus 36 is this point, stationary point is a minimum point. At x is equal to minus 8 by 3, place this here, and this x by 3, 8 by 3, this gives a negative value. So this negative value means that this point at x 8 by 3, 4000 by 27, this stationary point is a maximum point. This stationary point is a minimum. There are 2 points. This stationary point is a minimum point, and this stationary point is a maximum point. Let's solve question number 2. Let's move to similarly for this one, and let's solve this question number 3. The equation of curve is let's solve one of the find the coordinate of the stationary point on each of the following curves and determine the nature of each of the stationary points. So let's solve this f part. So let's solve this 2f first, and then this f part, this is y, and we have to find the stationary point. So this is u and this is v. So uv, we have to find these values, and this dy by dx is equal to 0. The first derivative is 0, so this is x is equal to 2 or x is equal to minus 4. At x is equal to 2, y is equal to minus 1. So the first stationary point is this. For x is equal to minus 4, y is equal to minus 30. By substituting in y here in this y, value of x, and we get the value of y. Minus 4, we have this. So the two stationary point, one is 2 minus 1, and the second stationary point is minus 4 minus 13. So let's take the second derivative. This was the first derivative we had. Now takes the second derivative. The second derivative, we have this value, and at x is equal to 2, this is 0, this is all 0, this part is 0, and because at x is equal to 2, this part is 0, so this x is equal to 2, this becomes positive, and this become positive. So dy by dx is positive, means at 2 comma minus 1, this is greater than 0, so this point is a minimum point. So let's check the other stationary point, minus 4 and minus 13. So this value, just substitute it in this value. So minus 4 will substitute, this will give 0, and this is minus 4, this becomes minus 4 means minus 3 cube. This cube gives an odd number, so gives a negative value. So this negative value will give a negative value. So this is negative, so this is the maximum. So this stationary point is the maximum point. Now we'll move to problem number 3. The equation of this, find dy by dx and explain why the curve has no turning point. This curve has no turning point, so we see that why this has no turning point is this curve has no turning point. So this is y, 2x plus 5, x plus 1. So we take the derivatives. For first derivative, dy by dx is equal to x plus, this is u, this is v. So we have taken out this. So this is yes. So dy by dx is equal to this. So dy by dx is not equals to 0, because this is always positive. At x is equal to minus 1, we have we never gets 0 here. So if we have no stationary point, so so this point has no, this shows that this has no stationary point. This is the result, this is the proof. This is not equals to 0, so there is no stationary point. So let's solve question number 5. The curve this has a stationary point at 1 comma 3. Find the value of a and value of b. Determine the nature of the stationary point 1 comma 3. Find the coordinates of the other stationary point on the curve and determine the nature of this stationary point. So let's solve question number 5. So we have this stationary point. So y is equal to x cube plus ax plus b, and the stationary point at 1 comma 3. So we will place this value here 1 and 3. We will have this equation a plus b is equal to 2. Takes the derivative of this dy by dx, this 3x square plus a, this is dy by dx is equal to 0, and placing the stationary value 1 here at x value, this 3 plus a is equal to 0, so a is equal to minus 3, and a is equal to minus 3, means we place this value here, minus 3, no, sorry, in equation 1, this becomes minus 3, so the b is equals to 5. So a is equal to minus 3 and b is equal to 5. So takes this dy, the second derivative. So we have these values, and this 1 3 is a stationary point. Now we have calculated the a and b by using this differentials, and in a part b, we have d double derivatives equals to this 6x at 1 comma 3. This is stationary point 1 comma 3. Place the value 1 here in the place of x. So this is 6 greater than 0. So this is, the slope is rising now. So this minimum point to uprise. So this is minimum point. So 1 comma 3 is a minimum point, and 3 is now placing the values 3x square and placing a is equal to minus 3x, and this y is 5. So c is equal to 3x square minus 3. This is a is minus 3. So taking the first derivative, this is 3x square, this is minus 3. So minus 3, so x square minus 1 is equal to 0. This is x minus 1 and x plus 1, because a square minus b square is equal to 0. So a minus b, a plus b. So x minus 1 is already calculated. So x is equal to 1 is obtained. So x is equal to minus 1. This part is equal to 0. So x is equal to minus 1. So at x is equal to minus 1, this y is equal to 7. So this is another stationary point, and this is stationary point. By placing this value, this becomes minus 1 here, minus 1 comma 7. So in placing minus 1 here, this becomes negative. So this is negative, means the slope was maximum and then falling down. So this is maximum point. So at minus 1 and 7, this curve gives a maximum point. This was the required value. So now let's solve problem number 7. The curve has a y is equal to ax plus bx square, has a stationary point at minus 1 and minus 12. This curve has a stationary point at these values, at these coordinates. Find the value of a and b and determine the nature of the stationary point 1 minus comma 12. So we have to find the nature of the stationary point and value of a and b. So this is y is equal to ax plus b upon x square, and by placing one and minus 12, because this is 1 and minus 12 is the stationary point of this. So in place of x, we will place minus 1 and this is minus 12, because minus 1 and minus 12 is the point where the curve is given, the stationary point. So this is b minus a. So by placing this, b minus a is equal to 12. So from the second, taking out the differential, first order we differentiate this with respect to s to get this one. So and this is a minus 2b upon x square minus 2b upon x cube is equal to 0, and by placing minus 1 and 12 at this value, so we have a minus 2b upon, in place of x we can place -1, so this is a minus 2b. So this is 0. So we have this in place of this becomes a minus, this is -1, so this becomes plus a is equal to -2b. So this is a this is from here a, this minus is becomes plus, a plus 2b is equal to 0. So this a is equal to -2b. So this a minus 2b, we put this a is equal to -2b at this place, at this place. So this is -2b. So from this a, b plus 2 minus plus 2b is equal to 3b is equal to -12. So b is equal to -4. So this -4 will be placed here at this value. So this a is equal to -2 and this is b is equal to -4. In this place -4, so this a is equal to 8. So a is equal to 8 and b is equal to -4. This is the values we have to get. So we have placed the value in the curve and its differential to find the value of a and b. So by using these values, we place the coordinates here and in this differential and place it equals to 0, because this is a stationary point. Because stationary point, we use this, and by substituting values we have calculated the two equations. By the first equation and the second one equals to 0 to get and find this a and b. By solving this we have obtained this. Let's this is dy by dx. Now substituting the values in place of this, a is equal to 8, so we have placed it 8, and this b is equal to -4. So at this place this is -4, so this is 8. So the first derivative is equal to this. So the first derivative is this. So the second derivative, this is 0 and this is -3. It will go upside, and then -3 and then x -4. So it comes from. So the second derivative is this. So this is -24 upon x square. For this coordinates, place this -1 here. So this will always gives you a negative value. So this is less than 0. So this point is the maximum point. So the slope is falling down after a peak reach. So this is a maximum point. So this -1 is a maximum point. So let's move to a challenging problem. Number 8. 168. This curve has a stationary point at the point this. This curve has a stationary point at this. Find the value of a and b the same way that we have obtained earlier. Find the coordinate of the second stationary point on the curve. Second stationary point, determine the nature of the two stationary points, and find the coordinate point of the curve where the gradient is minimum and state the minimum gradient. So this is a challenging problem. So this challenging problem. So the stationary point is given. This is stationary point. So we place this value in this curve to get the value, one equation, and then take out the differential. So 3a plus b is equal to, on simplification it gets this value, and take out the first derivative of this one. So we take the dy by dx is equal to this, and then equals to 0. So this gives us this a is equal to -6. Then by placing this a is equal to -6 from this differential equation, this we place this in this one. Placing a here, then we get the b value. So the b is 4. So a is equal to this and b is equal to 4, like the earlier problems. And then part b, this part b is equal to this is 6 x square. This is the differential, first order derivative. In place of a, we will place this value minus 36 here. So minus 36, we take out the 6 common, so x square minus x plus 6 is equal to 0. So this is this, and we have this differentials. This is two parts, x plus 2 is equal to 0 or x minus 3 is equal to 0. So if this is 0 or that means 0, so we have already minus 3 has already calculated. So this is x plus 2 is equal to 0. So we take out this minus 2 in place of this equation. Y, here we will place this value after substituting the value of a and b as calculated here, and this one. So by placing this, y is equal to this. So x is equal to, for x is equal to this, y is equal to 48. So the other stationary point is minus 2 and 48. Minus 2 and 48 is the other stationary point. So second derivative is this 12x. So this 12x minus 6. So this second derivative is this. At this point 377, this is the minimum point, because at this is positive, so this is greater than 0, so this is minimum point. At this stationary point is the minimum point for this curve, and for this value, if we substitute here, we will get the negative value, so this is the maximum point. For the other parts, we have to plot it, so we have not done it. So let's move to in the next session. We can draw the figures in part D to describe all these things. So in the next session we will discuss 12.10, some practical maximum and minimum problem, very important. And till then,